One, two, three. 1, 2, 3. 1, 2, 3. 1, 2, 3.
Please work your way to your seats. We'd like to get started. Wow, I didn't know I had that kind of power. Thank you for coming. My name is Mark Davis, and you'll see more of me later. But I'd first like to introduce Dean David Meyer of Tulane Law School. Dave?
Thank you very much. Thank you very much, Mark. It's really a great privilege for me to be able to welcome all of you to Tulane and to New Orleans on behalf of Tulane. Obviously, a place here in New Orleans with deep historical ties with France. So it's a special privilege and honor for us to be able to take part in welcoming you and co-hosting this program. It's also worth noting that our university and the law school, but every unit on campus, our ties with France are not only historical, they're also very much active. And it was my great privilege to meet Gregor Trumel, the Consul General of France here in New Orleans last August. Very shortly upon his arrival, so we were honored that he came, made the trek to Tulane immediately upon arriving, and that was for the first part of what I think a forerunner of this program, and bringing together people with backgrounds in science and policy to work together in addressing the most challenging issues before our society. I will, in introducing this, I just have to acknowledge that it was not lost on me the acronym for this program for the French American Climate Talks turns out to be FACTS, which is, of course, should be the bedrock of any engagement with the issues that relating to climate change, but of course is also a commodity in too short supply, generally, in the fiery debates relating to climate change. So we're thrilled to be able to welcome you to campus and to partner with you in hosting this important discussion. With that, I will turn the microphone over to Gregor Trumel, who, as I mentioned, is the Consul General of France and arrived last August into this role and already very much a partner here at Tulane. So, Gregor.
Thank you, Dean. I've prepared my paper because that's science, you know, hard to improvise. Ladies and gentlemen, mesdames et messieurs, it's an honor to open this great FACT conference today. And from the beginning, we have agreed with the French Embassy and Tulane University that FACT New Orleans should not be another lecture, just one more debate on climate issues. We wanted something strong, a real step in the debate between France and the US on a major issue. Raising awareness is the raison d'être of these Franco-American climate talks. These talks are scheduled in 7 cities throughout the United States and Canada. They involve leading scientists, NGOs representatives, politicians, journalists, and entrepreneurs. The facts about climate change are well known. They can no longer, in good faith, be denied. As we say in France, les faits sont têtus. Facts are stubborn. Some people pretend that climate models might be wrong. Unfortunately, a sea level gauge doesn't lie. What are these facts? Global warming is largely due to the action of man. The concentration of CO2 in the atmosphere set a new record in 2013. We can already see the terrible effects with the increasing number of severe climate disruptions. Flood here, drought there, hurricanes in places where they did not occur before, which is not the case for New Orleans, unprecedented long and cold winters. This is of course true for Louisiana as well. What are the consequences of climate disruptions? Starvation, migrations, and most probably wars for water and lands. Some low-lying lands are already threatened by ocean rise. Climate disruptions are a threat to peace and security. This is not catastrophism, ladies and gentlemen. Climate change will affect our daily life, and if we don't strongly react quickly. This is the background of our meeting today. Faced with these challenges, France is acting aware of her international responsibilities. We are working in 3 main directions. I would like to share them with you to launch our discussion today. First, we want to make sure the international community acts collectively to address these challenges. A few years back, referring to climate change, French President Jacques Chirac, who was a proud student in Tulane, perhaps you know that, in the 50s, said at the UN, "Our house is on fire. We need to act." UN Secretary General Ban Ki-moon added last month, "There is no plan B because there is no planet B," as far as I know. At the global level, after the UN summit, 2 world events are coming. First, in Lima, Peru, in December, and then in Paris, France, at the end of 2015. It is an opportunity to reach a global and ambitious climate agreement, legally binding, that should lead us towards a net zero carbon future. In Europe and in France, we have taken and implemented measures to reduce greenhouse gas. France is also helping most vulnerable countries, and in New York, French President François Hollande announced a contribution of $1 billion to the UN Green Fund. Second message, fighting climate change must involve all stakeholders, not only government officials. For the Paris Climate Summit in 2015, we are already working with cities, regional authorities, NGOs, and private companies. And when I talk to CEOs in the private sector or to city or state official in Louisiana, and I was recently in Terrebonne Parish with my friend President Michel Claudet on the question of the levees, they tell me about their concern for the environment, in particular regarding the coastal protection and the lowlands in the states. We would like the Paris Summit to share solutions rather than sharing the burden. Third and last message, just to reassure you, combating climate change should be seen as it is, a great opportunity, not a constraint. There is a huge potential of economic development with the emergence of new industries and new markets. For the French Embassy and its Office for Science and Consulate of France in New Orleans, I would like to thank our partners and panelists today. The great Tulane University, who kindly hosts and leads our debates today. Prominent actors, people of action, concretely involved say yes to our invitation. I would like to thank them sincerely and warmly, if I may. I arrived in Louisiana 3 months ago, and I realized how people here are involved in the environmental action as the Pelican state is, due to its environment, exposed to the risks of climate change. France and Louisiana have in common to fight strongly for coastal restoration and protections of their maritime regions. I know we will work a lot together in that field in the near future, and I will commit myself as a Consul General as much as I can to connect searchers and public actors to share good practices, expertise, and means. I wish you inspiring and great debates. This is time to share. This is time to act. Thank you very much.
Again, my name is Mark Davis, and I'm the director of the Tulane Institute on Water Resources Law and Policy at Tulane Law School. And I would specifically like to thank the Tulane Center for Bioenvironmental Research for helping to put this event on. They were so helpful that they didn't actually have to come up to the podium. That's influence. As you just heard, that the world's changing around us, and that climate is one of those things that is changing, and that one way or the other, people are authors of this change. And similarly, people will surely be beneficiaries and victims of these changes. The climate talks that this particular session is part of, and it's only one of several being held around Canada and the United States, is aimed at promoting a better understanding of how climate's changing, why, and what we might do to contend with it. It's not an abstract conversation. The next round of global climate talks are scheduled to be held in Paris in 2015. What goes into those and what comes out of those is very much something that should concern us all. And we're delighted to be part of the conversation, and we're very delighted to have you here too. But a lot of what you hear in public life, the media, political speeches and the like, focuses on either, great hopes, blind fears, all sorts of things which in many ways almost prevent real discourse from happening. Well, there will always be things we don't know. There will always be new things we do know. And there will always be costs to anything we decide to do or don't do. So it's not so much a matter of deciding a course of action. I don't think we can do that in this room today. But I do think that there are ways that we can begin to put this conversation on a more useful footing. And that's, in many ways, what I think this series of talks is supposed to be about. Because when cattle herds in Texas are being moved out of Texas because there's not enough water or forage for them, in large part because of changing water budgets and climates, that's important. When businesses, like in the insurance markets, investors, even members of the energy sector, are making climate change and its effects not only on their business model, but their ratepayers, part of their business model, that's something worth paying attention to. When folks like retired Marine Corps General Anthony Zinni and Admiral Frank Bowman write, as they did about 2 weeks ago in an op-ed, that climate change and its implications are matters of national and international security, and quite frankly, we're at a different place than we have been. And it's a place that I think takes us beyond merely talking about things that are too dire for many people to imagine, things that are not the realm of fatalism, because all too frequently we go from denying problems to being fatalistic about our ability to do anything about them. It's that management ground in the middle where you can take stock of what's happening, take stock of your options, and in many ways take control of your destiny, that I think is where the conversations today are intended to take us. These are things that are not new to anybody who lives here, because in many ways, the survival and sustainability of this region and its culture and its economy are just microcosms of things that are happening elsewhere on the planet. It's not a question of standing pat, and it's also not a question of packing up and leaving tomorrow. Some hard decisions are going to have to be made, and they're going to have to be informed ones. So that'll be what we're looking at in our panels today. But before that, a couple of logistics. First of all, please silence your phones. If you get a call or have to make a call, please step outside to do it. Also, there are people who will be joining us throughout the afternoon. There are students who have to go to class. There are people who are still looking for a parking place. So when you see people coming in, please be courteous and quiet while they join the conversation. And this is intended to ultimately be a conversation. It'll be not just a series of presentations, but it will be essentially a moderated discussion. And ultimately, we'd like you to be part of it. In fact, if you think of things that you would like to see the panelists take up, we have Corinne. Can you hold up your hand? There she is. She can give you an index card. In order to make this as manageable as possible, she'll take your cards, we'll sort them out, and we'll try to bring that to the attention of the panel. Those are the things we're trying to do today. Also, obviously, a panel of this size and one that is focused on science and policy, there are perspectives and issues and topics that aren't represented. That's not inappropriate, but this is not the extent of the conversation. The conversation goes on outside this room, it goes on in your communities. We just hope this is a helpful piece to it. I would also suggest to you that there is a program in the back. If you don't have one, grab it. You might want to share it with someone later, or you might hear something that compels you to approach a panelist today and ask for an autograph. It's a great way of Christmas is coming. But with that in mind, the program today is going to be set up in two panels. The first panel, and I would ask our panelists to please take your seats now, is the science panel, where we have a representative sample of some of the climate scientists, ecological scientists, that were most experienced not only with the issue of climate change, but of South Louisiana. And we also have some international perspectives. The first panel will be made up of Professor Donald Bosch, who's Professor of Marine Science at the Center for Environmental Science at the University of Maryland. And those of you who think he looks familiar, it's because he is familiar. He was born, you were born here, were you not? And he has spent a substantial portion of his professional life dealing with the issues of the Gulf Coast in Louisiana, including a stint on the Deepwater Horizon. What was the formal name of that group? Tulane, yes. The Oil Spill Commission that was put together to help figure out what went wrong and why. We have Dr. Virginia Burkett, who's the Science Director for Climate Change at the U.S. Geological Survey. She was also a lead author on the United Nations International Panel on Climate Change, dealing with aspects of how climate change will be affecting the communities, particularly in this hemisphere. She also has some new duties at USGS that she may enlighten us about. And we have Dr. Valérie Masson-Delmotte, a senior scientist with a French climate research center. I tried to pronounce it, I will not. She can do that for you. It would be an international incident if I went further on that. But her work on paleoclimatology has been reflected in her role as a lead author on a chapter on paleoclimatology by the IPCC. And I don't think anyone else on the panel can claim this. She was also named France's Women's Scientist of the Year in 2013. And finally, we have Dr. Tor Tornqvist. Tor is a professor of geology here at Tulane and chair of the Department of Earth and Environmental Sciences. He's made a lot of, I've worked with Tor personally on all of these issues, and I can tell you that he's good enough that he's even educated me. The way this is going to work, we've asked each of these panelists to do about a 5 to 7 minute presentation explaining what their interest is, why they think this is an important thing to share with you. And then we're going to have a conversation. I will lead it, but it's also going to be internal. Because one thing that is important to realize is that scientists are not necessarily, We're not engaging these people as political scientists, economic scientists, policymakers. We're trying, if nothing else, to help figure out where are the lines between policy and science so we can better understand where the lines are between other disciplines, because this is hard stuff and it demands respect. So I'm going to begin with Dr. Donald Bosch.
So thank you, Mark, and I want to thank the French Embassy for holding these talks around the country and Canada, and also thank them for inviting me back to my hometown and my alma mater, actually, as well. So it's good to be here. Let me orient myself to the clicker. So I have had the good fortune and responsibility of participating in a number of U.S. national assessments of climate change impacts in our country, in the United States, including the first two of the national climate assessments, one going back, the first one on the upper left, going back until the year 2000. Virginia is going to talk about, she played a leadership role in the latest national climate assessment. You'll be hearing a little bit more of that. Actually, though, and then in addition to that, I served on a committee of the National Academy of Sciences back in the early days of the Obama administration, when we thought there was some grand solution before us, and we needed to act before to get our story together for this country before international action overtook us. Well, neither of those things really happened. I've actually had a lot more success in terms of, as a scientist, having an impact on public policy, working at a state level in Maryland, where I live and work now for the last 24 years, because we've had the political leadership that's willing to listen to the science. And so as a result of that, I was back in 2007, I was asked to lead an effort that helped inform Marylanders about what the consequences of climate change could be for them, not just polar bears, not all the things you hear about, but what is the place that we live. And that assessment was very effective in doing two things, and these two things are related and need to be addressed together, in my view. Both getting public opinion, in this case political action, in our General Assembly passing legislation that says we need to do our part to reduce the amount of warming of climate change that we have by reducing our emissions. So we now have, as a matter of state policy, a reduction of 25% of our greenhouse gas emissions by 2020. That's called mitigation in the trade. And the other, of course, is that we need to prepare for the climate change which is already on us and that we see coming down the pike. That's called adaptation. So those two issues, mitigation and adaptation, my estimation as a scientist, go hand in hand. We can't choose one or the other. We have to do both, because we have to address the changes, the risk of climate change, but also we can only limit the extent of climate change we have to take by mitigating, reducing our emissions to slow down this process to the degree possible. And this has led to a number of other calls that we've had. Most recently, our governor asked us to develop the best projections locally for sea level rise so that we can plan for that. So we now have policy, first instituted by executive order and now by action by the General Assembly to plan for this level of sea level rise. So all of our state investments, highways, buildings, everything now has to plan with this in mind. Now, you'll be hearing a lot more about all these kinds of scientific assessments. One of those, which is the biggest kahuna of the scientific assessments, is the Intergovernmental Panel on Climate Change, which you may be familiar with. Last year, that panel produced, and early this year produced its reports on the fifth assessment. And just last week, they issued a synthesis of those findings. I would really urge you look at that, because it does a splendid job of telling the people of the world several things. One is that climate change is already occurring. It's already having significant impacts. Number two, that it's, if you ask the question, how much is human caused? The answer, the scientific answer is that basically we can account for all of it. due to human activity. So it's all caused by human activities that we've seen. In fact, some human activities have slowed the rate of climate change by putting more particulate matter into the atmosphere. So we're in charge. We're the responsible party here. Thirdly, it sets a roadmap to say if we're going to avoid really serious harm going forward, this is how much more carbon we have to emit. So we have a budget now. And so all of those things are as much as facts as you can, science can get. So this is a figure from the IPCC report, and it shows you two curves with uncertainty levels, boundaries around them. So this is meant to tell you that if you ask the question, how much will it warm, the primary answer to that question is that it depends on what we do. Okay, so there's a big difference. There's no overlap between the low emission, which is basically smash on the brakes, reduce our emissions as fast as we can, so that before the end of this century, we're actually having zero emissions or less than that, compared to the business as usual continued growth. Those differences are real, they're substantial. Sure, there's some uncertainty within those boundaries, but this is what we have to, this is the reality we have to deal with. If we then, unfortunately, the light is not allowing you to see the color here, but you'll have to use your imagination. If we look at the United States, we'll see those scenarios. The upper left one is the rapid reductions, the lower right one is unrestrained emissions. You can't see the colors here, but basically it gets hot everywhere under the unrestrained emissions. Hot of the nature of 7 to 9 degrees Fahrenheit, average temperature hot. And guess what? Those differences, that increase in temperature is greater in summer than it is in winter. It isn't, we're gonna be warmer winters, but really hot summers, serious heat waves, really life-threatening conditions. That's our future if we don't try to slow it down, turn it down. And we have something in the upper scenario that suggests that we're still going to have some change that we have to adapt to in any case, even if we are successful in doing that. This is another thing which we don't think about, which some of my colleagues will talk about, is that climate change, global warming also affects water, the water budget, where the water comes evaporated from the Earth's surface. As it gets warmer, more of it evaporates, but it doesn't come down where it evaporates from. It's located, translocated, so that to the north, you see the darker colors in these two graphs, wetter conditions, and we're already seeing that, more precipitation, and to the south, in our latitude, southern Europe as well, drier conditions. And so you might think of this, and it's enigmatic in a place like southern Louisiana, that we actually might have, this might produce some severe drought-like conditions during much of the year, particularly you see in the summer and fall, but that we will have, at the same time, while that's happening, you might have increased river flow because the areas to the north of us are getting wetter. Now, this is just precipitation. It doesn't necessarily translate directly to river flow because you have evaporation and so on from that. The other thing which is really striking is that the episodic nature of rainfall is already changing pretty dramatically and is intended to change. So we will have heavier downpours punctuated by long periods of dry weather. Enormous consequences that for agriculture, for water supply, a whole variety of things. And if you're living down here on an area receiving water from the river, is what happened here in 2011 and 2012 when we went from one of the highest flows to one of the lowest flows, is this a harbinger of things to come? So armed with this experience of trying to get scientific advice into the public policy arena, I became convinced that this is a really long-term adventure, and that one of the things I could do as an educator is to work harder. I've spent all my life in higher education, at education of all of our children. And so we have a program in Maryland and Delaware where we really are focusing on making sure that all of the students in our schools actually are climate literate when they graduate. And this will be done not by putting yet another curriculum requirement, but by riding the back of and empowering the next generation science standards, which our two states are in the process of implementing. and we also have elements in higher education so that every student, whether that student here is a Tulane art major, business major, comes out and is educated about climate and why things are changing and what are the options so they can become informed informed citizens. And then finally, let me just close on this. It was in the Washington Post this morning. This is Tom Tolles, the well-known cartoonist. I don't know if you can read it in the back. Here you have a tidal wave, tornadoes, lightning and thunder, and the little elephant sitting down there is saying, the votes have been counted. This isn't happening. You all know about the election. We just said Tom Tolles is right, seen in the bottom. He always has this little note in the bottom, and he says, wave election. Green wave election, no. So we have a real challenge. Are we going to go forward with the change, the political changes that Americans have elected to take, with trying to take, okay, we can have earnest disagreements about what do we do about it, how do we find the solutions, but let's get beyond having the science politicized and rely on the science that's been produced, which is very powerful as we go on. So thank you very much, and I yield the floor.
Thank you for that, Don, and thanks for using French and showing me up. Appreciate that. Oh, and I'd like to thank the Times-Picayune for the gift, tape recorder. It's appreciated. Our next speaker is going to be Dr. Valerie Masson-Delmotte, bringing perspectives from a different point on the map and from a somewhat different point, from a discipline standpoint. And I know I, for one, am looking forward to learning.
So what I wanted to say is that climate science is expensive. It requires global observing systems to monitor changes in the climate on the long term, and it requires heavy computing facilities for climate models, which are the tools based on physics that we use to anticipate future risks. So the results of the climate science is clear. Climate is changing. Many of the changes that we observe are unusual and unprecedented in the context of decades and sometimes longer. One example is sea level rise, something like 0.7 foot during the last century, and that's unusual in the context of the past 2,000 years. The increasing temperature during the last century is also unusual in the context of more than 1,500 years. So it's not part of a natural rhythm, it's something new that's happening. The human influence on the changes is clear, and it can be demonstrated by the role of human activities in the global atmospheric composition. There is no doubt that our activities lead to increase in the concentration of carbon dioxide or methane. We can prove it. It is the current levels are unprecedented in the context of the past 800,000 years. But we can look at the deep geological past. 3 million years ago, we had the same amount of CO2 in the atmosphere than today. Climate was warmer, sea level was higher, and we don't even need models to look at that. So it's just based on the Earth's history. Climate is changing, and it already has impacts. It's not just theoretical. It has impact on water, on plants and animals, and on people, especially those that depend on their local environment. The next feature is that, based on physics, we know that increase in greenhouse gas concentrations will lead to further warming. The human influence, the way we measure that is how much heat is trapped and doesn't go to the space because of the way the greenhouse effect is working. The influence of human activities on climate has doubled from the 1950s to the 1980s, and it has again doubled from the 1980s to today. So it's a global experiment that we are doing on the climate system, and what we see is only the beginning of the response, and it will go on for decades to centuries. So that's the other important point. The time scale of the climate system of the carbon cycle is long. So many of the changes that we are doing, they pose a question of commitment and sometimes also irreversibility on a human time scale. So the good news is that climate science has made major progress, and we can use that for guiding adaptation strategies. And as it was shown, the key feature that will define the path on which we are going is cumulative greenhouse gas emissions. So far, we have emitted about 2/3 of the CO2 that would ultimately lead to warming above 2 degrees Celsius, 4 degrees Fahrenheit, compared to pre-industrial climates. So this is clearly showing the scale of the changes that are expected if we want to control the speed of climate change. In the high-end scenarios, we expect a global warming of about 8 degrees Fahrenheit by 2100, but it doesn't stop in 2100. It goes on in the next centuries. And it would bring us completely out of the range of natural climate variability that our species has known, both in magnitude and in rate of change. Climate has changed in the past, for instance, glacial interglacial cycles. Just think that from a glacial to an interglacial cycle, the pace of global temperature rise was only 2 degrees Fahrenheit per 1,000 years. What is really striking for me as a past climate scientist is the speed of the climate change that is expected to happen. And therefore, the way I would like to frame it is that by emitting greenhouse gases, we are creating a risk enhancement system. And what are the risks that are strongest for this area? A warmer atmosphere can convey more moisture. So a warmer climate is also associated with more heavy rainfall. In the high-end scenario for this area, it's 30% more amount for the most heavy rainfall events that are expected. It's also enhancing heat waves, of course. It may enhance the strength of the strongest hurricanes, both for wind speed and for the amount of heavy rainfall. And obviously, it's also acting on sea level. And my final point will be on sea level. I work on ice cores from Greenland, from Antarctica. What does the past tell us? It clearly shows that when we have polar warming, not that much, a couple of degrees Fahrenheit more than the pre-industrial level, and when it is sustained on the long time, more than 100 years, it leads to melting of ice sheets and sea level rise by much more than 3 feet over the long term. So clearly, what I wanted to say is that we have climate science that can inform adaptation or mitigation. That is what we can provide to the general public, to policymakers, and I agree with you, to our students and the young generation. What I'm most proud of is the fact that some of the results we've obtained based on ice cores, they are part of the standard curriculum in France at the high school level. Because these past changes, they provide a framework against which you can judge the importance of future risks. And finally, I wanted to finish by uncertainties. When we talk about climate science, we always get questions about uncertainties. How reliable are climate models, for instance? You know, they are human constructions, all models are known to be imperfect. The fact that we can understand the past and that we can model the big features of past climate changes, for me, is crucial for the confidence I have in the ability of climate models to provide well-informed guidance on future risks. Thank you for your attention.
Our next speaker is going to be Dr. Virginia Burkett. There we go. She'll be speaking from her seat.
Okay, that's it. Okay, perfect follow-up, Valerie, to Don, and I hope I can complement what the points that you were trying to draw out here. These are from the most recent IPCC report. Again, you can see the temperature projections into the future, and I got it, Mark. Okay, on the left, and we've got the higher emission scenario and then the lower emission scenario. And you can see up until about 2050, there's an overlap. So regardless of the policy choices that are made and the actions that are taken, in the short term, the climate is going to continue to warm because of changes that are already basically made to the atmosphere and the projections of just current business as usual in the short term. So up until about 2050, they don't diverge. And in the same thing in terms of the sea level rise projections on the right, now these are the projections from the most recent IPCC report from Valerie's volume, which was the physical climate science. And I worked on the impact side of thing on coastal impacts specifically over the past few reports. And you can see that the projections go up to 1 meter on the high end, roughly 0.98 meters, and then on the low end, down around 2 meters. The blue are the lower emission scenario out to 2100, and the red or the orange color are the higher emission scenarios with the range of the model outputs. So those are the process-based models. Like Valerie was saying, there's our ability to model ice sheets is improving, but the process-based models still give us, if you just use those alone, this lower extent of sea level rise up to about 1 meter. Now, this is also a quote here from IPCC 2013, when the Working Group 1 report, the physical climate science, came out, that many of these semi-empirical model projections, as she was saying, the ones that really look at how, in the paleoclimate and even in the recent changes, how the warming has driven changes in sea level, just those connections, and results up to about twice as large. So here you've got up to 2 meters. And a colleague of Dr. Bosch's and mine, we kind of like this because it shows the range of the responses of climate scientists globally, not just the IPCC consensus, which is somewhat conservative. But if you look at the range of plausible changes in sea level in response to warming through 2100, at the wide range of literature using both the process-based and the semi-empirical model projections, it goes up to 2 meters. And in this assessment here, or this synthesis of several hundred scientists' viewpoint on what sea level rise could truly be by the end of the century, you'll see the NOAA assessment. And I was a co-author of that report. And we've got the highest range in the red dot, the lowest range in the blue, but we also present this intermediate high and low, which for the United States is 1 to 4 feet. And that's what we used for our national climate assessment in the United States, this recent one that Don had mentioned. Now, not only does, of course, the warming affect the steric sea level rise, that expansion due to the warming, the thermal expansion, and the decline of land ice, it also affects precipitation patterns and the flow of water and sediment to the coastal zone. But also it affects the propensity for the development of tropical storms, hurricanes we call them here. And both the IPCC AR5 and our U.S. National Climate Assessment, both released within a month or so of each other, both found an increase in the intensity, frequency, and duration of the number of strongest hurricanes that have formed in the North Atlantic Basin since the early 1980s. That these increases in intensity are linked in part to higher sea surface temperatures. And by late century, these models that are used by the climate scientists on average project an increase in the strongest hurricanes, both the rainfall and the wind associated with the storms, which have tremendous potential for places like New Orleans. But New Orleans isn't the only place. In the Mississippi Delta here, we have a lot of folks living, but globally you can look, this is from our prior IPCC report, we classified deltas as hot spots of societal vulnerability to climate change. And you can see where we've got over 1 million people exposed, where those bright red dots are, and most of these people live in Asia. So the vulnerability for America is serious. For this place where we sit today, it is serious. But it is also a serious challenge to people in developing parts of the world that don't have the institutional capacity or the resources to adapt. When my parents lost their home in Hurricane Katrina, they moved off the coast. In lots of the world where these things are happening, people don't have those sorts of resources. Here's a photo of a graphic of land loss in coastal Louisiana. All of that red area in the Mississippi Delta was converted from land, marsh, barrier islands, levee ridges, that sort of thing, to open water in just a flash of geologic time. The place where we're building land now is in the Atchafalaya Delta, and that's because of the fresh water and sediment from the river actually being able to reach that particular open embayment there called Atchafalaya Bay. But you can see in the delta area, the Birdfoot Delta on the lower right, you know, the tremendous rate of wetland loss. When Hurricane Katrina crossed the Louisiana coastline, and that's that yellow line there, overnight during 2 storms, just 2 weeks back to back, Louisiana, this part of the state, lost 214 square miles of land. So it's not just sea level rise, it's not just increases in rainfall and drought causes these these brown marsh events in coastal Louisiana, where we have stresses on the plants that cause the plants to die and turn to open water. It's this combination of drivers that are associated with sea level rise and these other factors. This is the Chandelier Island chain before and after Hurricane Katrina. Tropical cyclones in this part of the world, counterclockwise rotation. That island chain was a tremendous buffer for storm surge that affects the erosion of the levees that protected this city. And as you can see, about 85% of the aerial, we call it subaerial extent of that island, the emergent part of that island was lost during Hurricane Katrina. Last slide, as Dr. Bosch mentioned, and the rest of the panel will focus on mitigation and adaptation, the combination of those actions. These are the key societal responses to climate change, can reduce impacts on coastal deltas and other low-lying coastal systems around the world. Thank you.
And our last presentation, before we get into the more entertaining part of the program, will be Dr. Tor Tornqvist.
I got it here. Thank you. So we have already heard a lot about sea level, and sea level is obviously only one of the components of climate change, but it's arguably the most important one here on the Gulf Coast. And as it happens, it's also something I'm very interested in. So I will continue talking a little bit about that. And in particular, I want to talk about sea level change, both globally and in this region, in a bit of a geological context. Valerie already introduced the whole phenomenon of glacials and interglacials, which is the larger context for the geologic time period we live in. And so I'll start off with a map. This is kind of an unusual way to project the Earth, but it's actually a very effective way to show past and present ice sheets. So what you see here are the 2 remaining ice sheets we have today: Antarctica here near the bottom and Greenland here in the top. And the reason I show this is that ultimately in the longer term, the future of coastal Louisiana and pretty much any low-lying coastal area in the world is going to depend primarily on what's going to happen with these 2 ice sheets. So the other thing you can see here, the other large white areas are ice sheets that don't exist anymore. This is the situation, the way the world looked about 20,000 years ago during a time we call the last glacial maximum. So obviously there's been tremendous change. There are huge ice volumes that existed on land and that melted and were transferred into the ocean. And there is a lot we can learn from studying that whole process. So to give you a better idea of what that actually led to, I'm going to show you a sea level curve that goes back about 35,000 years. So it actually starts prior to that culmination of the last glacial and then all the way into the present. This is actually a study that was published only a few weeks ago, and I think it's likely to become a very influential one. So what you see here, and I'll point out the vertical scale first. This is going from 0, so this is present sea level. Here we're down at minus 150 meters. So the low stand was reached just before 20,000 years ago and was a little bit more than 130 meters below present. So that's about 400 feet. So obviously the Earth is capable of seeing these tremendous sea level changes driven by long-term natural processes. So what happened in the last 20,000 years, we had this tremendous sea level rise where a lot of things went on. And you can see, if you look in detail, that this is not a straight curve. There are variations. There are times when there was extremely rapid loss of ice. So we know that these ice sheets have a tendency not to just melt gradually, but to do it in pulses that can lead to really catastrophic events. What you see here in this inset is basically the most recent part of the record when we kind of approach present sea level. And there is one point I want to highlight here, which is around 7,000 years ago. There is a prediction in the rate of sea level rise. And the main reason for that is that was the time when this huge ice sheet that covered a large part of North America had basically disappeared. Right? So after that, there was some continued sea level rise, but it was much slower than what we saw before that. And I'll return to that in a second. So if we now look at much shorter records that really take us into the present, this is a really nice compilation which shows these are different records from different parts of the world. And what is visualized here is a time scale that goes from the present here to the year 1650. So this is just the last couple of centuries. And it shows a trend that we really see worldwide, and that is an acceleration, a very distinct acceleration in sea level rise that started roughly around the year 1900. So really in the post-industrial era, or after the Industrial Revolution. So no matter where you go, we pick this up pretty much everywhere. So this is basically a combination of instrumental records, tide gauges that actually measure sea level continuously on the coast, and then these larger crosses back here are geological data that kind of give that longer term context. So if we then go to Louisiana and look at similar records, and I have to apologize, those of you in the back of the room may have trouble seeing this, but this is actually work that was done by one of my former students, collecting sediment cores here from the Mississippi Delta. And the main thing he did was put together this sea level record here, which goes from about 600 to 1600 AD. So this is a time period of about 1,000 years, which is really the pre-industrial millennium. And the important thing to look at here is just this long-term trend, which is a rate of about 0.5 millimeter per year on average. So what we do then is we compare that with measurements of sea level here on the Gulf Coast during the last century from tide gauges. And probably the best record is the one from Pensacola in Florida, a couple of hours to the east from here. And what we see is that the rate at Pensacola was a little bit more than 2 millimeters per year over, say, the better part of the last century. So what it shows is basically equivalent to what I showed for worldwide on the previous slide, that we see a very distinct acceleration on the order of, a factor of 4 to 5 during the past century, right? So what it also shows is that acceleration of sea level rise has already contributed to the coastal degradation that we see in this region. It's up to this point being a relatively small factor, but it's very likely to become a much bigger factor in the future. So when we look at these rates, and we look at this rate of 0.5 millimeter per year, and the rate for the last century that is on the order of a few millimeters per year, the globally averaged rate that we've seen over the past few decades is on the order of 3 millimeters per year, or maybe slightly higher. And that again brings us back to looking at the longer term context. And if we focus again on a longer record, you have to go pretty far back to see sustained long-term rates that are comparable to the rate that we're seeing in the present day. In this case, you have to go, oh, wait a minute. We have to go back to about 7,000 years ago, right here, and you see a distinct increase in slope and rates on the order of 3.5 millimeters per year. So again, this is that effect of the remaining big ice sheets here in North America that contributed to this rapid rise back then. It was gone after that, and things started to slow down. But of course, we now know that both Antarctica and Greenland are starting to lose mass at increased rates. So that's what's speeding things up again and bringing us back to conditions that we haven't seen in a very, very, very long time. So I think I would like to leave it here for now.
Well, all my questions were answered. As has become fashionable to say in the last few weeks, for those of you who haven't followed the debates in places like Florida and the like, I need to start by saying I'm not a scientist. And when I hear scientific presentations like this, I confess I'm both, intrigued, confused, and somewhat alarmed. So the first question I want to ask is, since you talk about these very dire conditions, or certainly dire trend lines, well, how strong is the consensus in the scientific community that these things are in fact happening? Because when I read in the newspapers and I go to fundraisers for candidates, I hear that there is, as was noted, a great deal of uncertainty. And honestly, I like uncertainty that works in my favor. I want to believe that this isn't happening. Help me out.
Okay. I wish I would like to believe like you that things aren't happening, that we haven't affected the atmosphere and the climate system and sea level as we are. But that was just a personal comment and not on behalf of the government or anything. But if you look at the literature, 97% it's not on? Oh, sorry.
See.
There. There have been several recent studies of the literature as a whole. They call them meta-analyses of the scientific study of climate change and the role of humans in influencing the climate. And I'm aware of 4 of these, and I'm not aware of any that dispute these findings or this sort of conclusion that 97 to 98% of the scientific literature supports this basic thesis or conclusion of the IPCC, for example, that humans are having an effect on the climate and that the humans are largely responsible for changes that we've observed in the climate system. And so for some reason, people, I think, maybe because the media has to cover both sides of things, but sometimes in the things that the people, the general public read, it seems like there's a split amongst scientists largely, but that's not the case. The IPCC report, for example, is the consensus of scientists nominated by the UN member governments globally, with 50,000 plus comments that we responded to just on the Working Group 2 report. So it does represent that consensus that is also held up in these analyses of the literature globally.
I will try to answer differently. You know how the science system is working. We are not paid to confirm what exists. We are paid to challenge the state of knowledge. And if anyone had a strong evidence for other drivers of the trends observed in the climate system for the past years, journals like Science or Nature, they would immediately take it because it would be such a discovery. It's not the case. And people are coming with new tools. For instance, climate models, there are several of them in the US, several of them in Europe. The newcomer is China. They develop several climate models. They repeat the simulations, they repeat the analysis, and they obtain the same results. So if you would like to have a fair debate on climate change in the media, as was said by some American colleagues, you would need to have 100 climate scientists that would say all the physics shows that when you add greenhouse gases, climate is warming, and one that would say, oh, maybe the ocean currents can modulate this, more or less.
I'd just like to add to my colleagues and say, you know, we're not making this stuff up that you saw, that there's real evidence that sea level rise is accelerated. We have real evidence that we're measuring temperature, and decade after decade, it's been getting warmer and warmer. It's going to be the warmest year around the world that we've ever measured. We have these models that are projecting about the future. You might have some doubt about it, but they're basically based on the simple laws of physics. If the greenhouse gas effect did not occur, we wouldn't be here. It'd be a cold planet, but it's warmed the planet. The greenhouse gas effect has been known for 150, 200 years now. It's not a question at all. The only issues are related to exactly how much and how fast, and that's what you've seen. This competition among scientists who are trying to get better and better model estimates. Honestly expressed is a range around those central estimates and the projections. So we're not telling you it's one number. We think it's within that. We have a high level of confidence in doing it. And I think if you're willing to deny the facts, to quote the title of this conference, then I think we do that at tremendous peril.
You want to take a whack at it, Tor?
Well, just one brief comment. You know, most scientists are pretty ambitious people, and they care about their legacy. And you know, I may not speak for everyone, but I'm sure I speak for the vast majority. I don't think many of us would want to be completely on the wrong side of history and known as like, yeah, these were the ones who just really didn't get it completely wrong. But I would also add that you know, there's been comments for many years about a so-called hoax or some kind of conspiracy among scientists. If there's one community where it's probably the hardest to set up some kind of conspiracy, it's probably the science community, because we are known for disagreeing with each other on pretty much anything you can imagine. So when there are a few of these remaining things we actually have such strong consensus on, I think that alone is a very strong indicator that there is probably some merit to it.
Well, speaking of that, since you've now confessed that you can all barely stand each other, don't like to work with each other, and that you have grand ambitions, unlike us noble, self-effacing liars, that and that uncertainty is a given in what science does. But aren't you supposed to be providing us with strong, conclusive consensus before we act? I mean, certainly that's a reasonable thing for people to want from science, isn't it? I mean, isn't that the nature of science, is to, in fairly short order, get us to the undisputably true? Or are you going to make us act when we're not entirely sure?
Well, we've done the job. We just showed you, you know, the result of 5 iterations of assessments, which have become more and more clear, more and more evidence that overwhelmingly demonstrates that the climate has been getting warmer. The climate's changing. That if we continue to grow emissions, there are a number of dire consequences that are likely to happen with very reasonable levels of certainty compared to the other projections that say, is there an economist in the house? We act on economic projections all the time that aren't even certain about the sign, that is whether things will go up and down. Here we're certain about the sign. We have a little bit of uncertainty about the range, and we're telling you most of the uncertainty is related. It's not really uncertainty scientific, it's uncertainty about what we will do about it. And here are here's the consequences of your action and inaction. So what do you want more?
So you're telling me, as a lawyer who works in a world of the preponderance of evidence, that I am holding you to a standard I'd never hold myself to, and I don't act on a different...
I think it's gone beyond the preponderance of evidence, is beyond a reasonable doubt, a criminal standard.
And we have to be honest. We can't tell you at the end of the century precisely a number. If we picked a number, it would probably be the wrong one. So these bands of uncertainty are important because that is the scientific uncertainty associated with our projections. But Mark, I'll also add that in addition to the physical climate science and the consensus on that, in the Working Group 2 report, we also concluded that we have observed, and we have a graphic showing all around the world in every ocean and on every continent, that there are observed changes that can only be explained and have been explained in terms of either generally it's the warming atmosphere, but in some cases it's a second order effect, like changes in runoff, for example.
Well, one of the questions that we frequently get on the policy side of things is, well, there are other explanations for these things. Oh, it's the sun cycles, or it is, you know, we have these natural pauses, that there's nothing really out of the ordinary here. What should we make of those?
So we work on it. And I think it's not policymakers that have suggested that solar activity has a potential effect on climate. It's climate scientists themselves. So what we do is that we use observations to estimate the way changes in the amount of energy supplied by the sun can affect variability from year to year, decade to decade. And the conclusion is clear. There's no increase in the output of energy by the sun during the last 50 years. This cannot by itself explain the warming trend. It's very clear. And however, we also work on the last 1,000 years. And the last 1,000 years is really interesting. You know, it's the historical period. We have lots of climate records from tree rings, from glaciers, from corals. We have a good knowledge. And we can look at this variability. Maybe you've heard about the Little Ice Age, the medieval climate anomaly. There's variability which cannot be related to that is purely internal to ocean atmosphere variability, which is not caused by anything outside the ocean and the atmosphere. And then we try to understand the role of changes in solar activity and also the role of changes in large volcanic eruptions. And if I can summarize this in one sentence, I would say that to my knowledge today, we stress a dominant role of major volcanic eruptions, you know, that place particles in the high atmosphere and have a cooling effect for a couple of years. And we can see now that the pacing of these large volcanic eruptions is a key player in the variability that we observe during the last 1,000 years, much more than solar activity, in fact.
So, yeah, one thing I would like to add, and because I think Valerie makes the point exactly as a climate scientist, when this question comes up as you pose it, oh, it's all natural cycles. You know, to me, it's completely baffling, the idea that climates would not ever have thought about that. I mean, that's the first, it's completely laughable. So it's, of course, the first thing we look at, and we've seen in these various presentations that, of course, we first look at natural climate variability because that's the context of what's happening today. The whole point is that what we're seeing over the past century, we simply cannot explain with only looking at natural mechanisms.
As scientists who are not only writing for your peers in the traditional scientific way, but finding yourselves in forums like these or being asked to advise policymakers, I mean, what would you suggest, you know, that we non-scientists, you know more about what you do, and how can you translate what you're into a language that others can actually learn from? Because there seems to be a lot of teaching going on in various realms, but not yet a lot of learning. I'm looking at you, Don.
Okay, Don.
What do you want to know about us? Strange as it may seem, that we're very conservative people in our own professions. It's a very conservative process. We demand lots of evidence, debate, discussion, and we aren't willing to accept new ideas unless they're well demonstrated. So the view that the climate science is some sort of a liberal conspiracy, you know, if you think about how the culture of science is very strange. in fact, what happens after every IPCC report is that there's a usual active debate by some scientists who feel that IPCC was too conservative. A good case is sea level rise. I'm glad you raised this question. It got me to, I was going to let
It's
sea
my
level rise
job.
alone to these experts, but sea level rise, the IPCC estimates that Virginia showed, you probably couldn't see the numbers real carefully, were actually lower than the scientific consensus estimates. I think you made that point. And if you look at the IPCC, they have rules of evidence in that the models have to be well validated. And we're talking about ice dynamics in which we are at the cutting edge. We don't have widely accepted models in terms of the ice dynamics of these polar ice masses. The IPCC projections actually assume that the Antarctica will build mass of ice, not melt, but build a mass of ice. So it has a negative contribution to sea level rise. But yet now we see, based upon satellite evidence, which we measure the gravity of ice on the Antarctic mass, that actually it's melting, it's losing mass. So that's a matter of scientific dispute, uncertainty, but it's taken a very conservative assumption. Now, why is Antarctica important for coastal Louisiana? Tor mentioned two ice masses, one on Greenland, that are left over, one on Greenland and one on Antarctica. If you had a cubic mile of ice melting from Greenland and a cubic mile of ice melting from Antarctica, which do you think will have the biggest effect on sea level here in Louisiana? We're close to Greenland, right? Wrong. It's Antarctica. Because the water redistributes as the gravity pull of the Antarctic mass is diminished, water retreats from Antarctica. Sea level goes down around Antarctica. It increases with distance from Antarctica. So our biggest stake is that we better understand what's going to happen in Antarctica, because it's very important to this part of the world. It's the largest big factor, the biggest unknown. And the IPCC is taking a very conservative approach to that. So we're conservative.
Valerie, I think.
In fact, I have a question for the audience. Who of you has been through a climate science class? Okay, you can see the problem. So when we speak with policymakers, they have not been. And just I have a mobile phone. On my mobile phone, I have alerts for news with the keyword climate. So social climate, I look at climate science, the way it's conveyed to the general public. It's convened, it comes from press releases with a few studies, scientific studies, not always the mainstream ones. And then there are also highlights based on controversies or things like that, and then highlights based on policy aspects. And for me, it's like an impressionist painting, you know? So there's a big picture on climate science, which we understand based on physics, based on the energy in the climate system. But if you only get these small touches of paint and you look only at them, it's extremely confusing. You don't get the big picture, and you understand that there's an issue on one minor aspect, maybe Antarctica or another one, but you don't get the big picture, and that's the problem. And I really believe, as you said, that education is the key. And you know, most of you had a history class, right? Why do you learn history? It's the past. But we need to learn climate history as well, because it provides a framework against which you can assess current changes and projections. And you also need basics about what is a climate model. A key feature I've observed is that economists, for instance, or policymakers, they believe that the future of climate is based on extrapolating observations. You know, you see the recent trend and you would extrapolate from that. It's clearly not the case. It's based on physics, models of physics that are used to evaluate the response of the system to a perturbation. And that's also something that's challenging to convey, to transmit, but it's feasible. So these are my comments on that specific question.
No? Okay. Well, looking around the globe, are there places other than New Orleans that have these problems that we should be? I mean, Tor had some dots on a map, but I haven't been to most of those. But from the standpoint of documenting that there may in fact be problems, and I think most of us go through life knowing that there will be problems. How do we translate, what we know into meaningful, action possibilities? Because obviously, in some ways, we're talking, an analogy maybe to medical science. You may well be diagnosed with something, but if the medical care is not readily available, if you can't afford the medical care, I mean, how do we deal with those issues so what we know actually can begin to shape better options?
I guess I grabbed the microphone too early because you can't change the question along the way. So if I may, can I give a very...
You may change the question via your answer.
All right, I'll just revert it back to the initial issue you brought up, and I'll be very brief. You mentioned, places other than New Orleans that are facing, in our particular case, sea level rise. Well, Virginia already showed the world map with, the real big dots that are mostly in Asia. But the one thing that I think is important to repeat, and some here in this room probably know this, but others may not, that when it comes to major cities in the US, New Orleans is not going to be number one. Number one is going to be Miami. Because especially in the current circumstances where our flood protection system has certainly improved, whether it's good enough for future Katrinas well, I hope we will never have to really test it, but we probably will. But Miami is defenseless, and building levees there is basically completely meaningless because the bedrock under the city is entirely permeable to water. So in other words, there will be major issues elsewhere, and Miami is certainly not the only other place that will strike probably before New Orleans becomes uninhabitable. And as far as the remainder of the question, I'm happy to put the microphone back on the table.
Always a prerogative.
Okay. Yeah, regarding the second part of your question about the role of scientists I'm sorry, I just talked.
You might hold it a little closer.
Okay. The role of scientists, I would not look to scientists to provide solutions or prescriptions. We are trained to study the natural world, describe it, and do our job, and to teach. Okay. A lot of us have taught at universities, but scientists are not the people that should develop, or I don't want to even use the word should. Some scientists may be involved in developing solutions, but in terms of looking at us, yes, scientists can help there, but in terms of making policy decisions, don't look to scientists to do this. I've also, in the literature, there's an interesting article that came out recently that showed that when scientists start making policy prescriptions and advocating certain actions by policymakers, that they lose credibility, which is an interesting thing for us to remember. We are scientists. We are not the policymakers. We're passionate, though, about, for all four of us, about the science that we conduct and from the synthesis end of things from IPCC, the scientists, that thousands of scientists from around the world, that science has come together, and that's what we try to present for policymakers. And we're passionate about, about that science, but that's where it ends.
So the next time I'm in the room with an elected leader on a matter such as, what we should do coast, what we should do with water supply, and that person says, what we need to do is get the politics and emotion out of this room. We should let the scientists tell us what to do. I should remind that person that that's in fact not the job of science. The job of science might be to inform that discussion, but not.
Exactly.
They're not going to be happy to hear that, I got to tell you.
Yeah, but they have to weigh societal needs and preferences against the natural system. Here in Louisiana, I'm real proud that the state of Louisiana has used the sea level rise projections in their coastal master plan. You know, I'm not sure of other states that have done that. Maryland perhaps has done that. But, you know, it's a very practical use of the science. But they also had to balance the need for transportation, waterborne transportation, for example, people that live in areas like the city of New Orleans, as well as the fish and wildlife needs for the state. And scientists, you know, we're good in our particular realm of study, but in terms of balancing those diverse needs and demands, that's where policymakers have to make informed decisions, hopefully based on the science to the extent that they can.
Well, that'll be a nice segue into our next panel. And I have one closing question on that. And that is, if you go back, not all that long ago, in fact, but certainly no more than 100 years or so, many decisions were made more locally. They were made by individuals on a family basis, an individual basis. But increasingly, we've seen government grow, we've seen businesses grow, we've seen civic institutions grow. Increasingly, decisions and policies are being made by institutions with missions, budgets, authorizations, and programs. And they don't learn quite the same way that I do. I mean, an interesting example that many in the audience would probably relate was the condition of our coast. Until the late 80s and early 90s, it was not the jurisdiction of any federal or state agency to see the coast was falling apart. So information documenting that didn't really have a place to go. Do you see that as a significant issue, or was that a local issue here?
I don't know whether that's true, Mark. Take the example you used of the deterioration of the coast. Those decisions regarding the levying of the river, regarding how we would allow oil and gas development to pursue, were institutional decisions. In fact, they were institutional decisions, at least in the former case, with respect to levying of the river, in which the basic science of what would happen in broad brush was known. And the decision was made to kick the can down the road and to get the benefits, short-term benefits for a generation or two, with anticipation that some smart people down the road would figure it out how to deal with it. This is the consequence of levying the river. The other example we saw in our tour with the French delegation today was the Mr. Go, Mississippi River Gulf Outlet. I think there were many people who basically anticipated what would happen, and yet we decided that it was in our short-term economic interest to do it. So I just think we should learn from those and be prepared to, the role science plays is not to make the decisions, is to help you understand the choices you have that would comport to the reality that would play out.
Well, with that, I'm going to ask that we thank this panel, and we'll move on to our second panel. We'll take about a 5-minute break so people can stretch their legs. Thank you.
I got a Republican governor.
Hey, Marie. The sound's not carrying back there.
I don't know.
Hello?
Some of it. I'm actually worried that this won't make it to the end. Okay, it will. The soundboard is back there, and there's a young gentleman in a blue shirt. Maybe he can help with that.
How you doing? No, I'm stuck inside now. I was cleaning my deck. I did get out. I think that's been re-cleaning my deck. So, you know, Don, all those great things they got to do something. They're going to look my ass. The joke of dancing, that's right.
What I'm going to do is say questions and answers. We'll try to follow in some way, get answers possible. I would, but I know that Virginia has to leave, so that's I got to take. Virginia's on the next this panel too. No, she'll be coming up for the Q&A at the very end. She's now the associate. She's now the associate active associate director.
You know, she's 3 years back and then that was I was coming on something. Having someone from outside come in, me having a woman come in, it was like,
Well, she compensates for that by being a scientist.
She doesn't put that on her resume. It's funny. It was a really great thing.
If we can take our seats again, we'd like to begin the second panel.
Look. This is all good. There, how are you? This is you too. You got my contact. Yeah, she actually Pierre from the Embassies of France. I connect with Kai. We're pretty good friends. So you were on the panel with this? I know it was too tight for you to get there, so thank you very much. It's just big celebration. I look like I'm happy to do it. So, Mr. Zarek is the head of Crystal Production. And just you know, yeah, well, check what it is. Good turnout.
Yeah, I had no idea what to expect. This is really good. I'm working on a little Twitter account. There's several people in the room that are on it. I guess that they're live streaming it online too.
Yeah. Oh my God! I'm doing my best to documentary.
All right. All right. The time has come. Leads, please. If our panelists could please come up and take their seats. Okay. Program making is not really what we should ask scientists to do in their capacity as scientists. This problem has some folks who are far more experienced with making policy. I'm sorry? Okay. Oh. Yes, probably that. Special question for Mr. Zerang. But obviously, when it comes to something like climate change, making decisions and turning decisions into actions is no easy thing, particularly since it has to be done at the local level, the national level, and the international level. It involves issues of uncertainty and urgency, which are not always on speaking terms with one another. We're very fortunate to have some very experienced people in this field. We have the Honorable Corinne Lepage, a former French Minister of the Environment and a current member of the European Parliament. She's also president of what we would call the French Green Party. She's a lawyer who specialized in public and environmental law. And for those of you who follow oil spills, which some people around here just around occasionally, she played a very significant role in representing the victims of the Aramco Cadiz spill, which, if you can remember back that far, was a very significant event in environmental, oil, and European policy. We also have Mr. Jerome Zerang, Z to his friends, and I like to count myself among them. He's the chairperson of the Louisiana Coastal Protection and Restoration Authority. It's already been referenced in the last panel that the Coastal Master Plan, which is in many ways the blueprint for charting a path towards some version of coastal sustainability and societal sustainability here in Louisiana, well, that's really the handiwork of the shop that Jerome has the honor of heading up. He previously has been a director of coastal resources for the Nature Conservancy in their Louisiana office, and has also headed the Terrebonne Parish Levee and Conservation District. And so I should let you know that he is very comfortable being friendly us from time to time. And also, knowing that he's also working on a place he's chosen to make his home, that he has a personal stake in it. He has degrees in zoology and fisheries biology from Louisiana State University. And our final speaker will be Dr. Daniel Zimmer. And he comes to us from the fields of agricultural engineering and hydrology, two disciplines that I personally can vouch for we need a little more help with. He has served as director of the World Water Council, and has helped shape the development of what many of you probably are familiar with, the hugely successful World Water Forum. He brings to us today, in particular, his interest in how water resources can be and stand to be impacted by climate change. Our first speaker is going to be Ms. Lepage.
Thank you very much. Monsieur le Consul, dear President, dear panelists, ladies and gentlemen, mesdames et messieurs. It's a great pleasure for me to be with you for this afternoon. First, I want to apologize for my English, and I hope only that you understand what I say. I am here as a policymakers and the lawyers, not as a scientific. But I want to say that climate change is a reality, that climate skepticism is an opinion. And the subject of this roundtable is adaptation. And adaptation signifies that we accept the fact of climate change. The cost of adaptation would be between $49 and $171 per annum by 2030. it's a lot of money. For the World Bank, the cost of adaptation will be in the range between 75 and $100 billion between 2010 and 2030. But unfortunately, we're waiting for a change of policies. Some explanations can be proposed. Cost-benefit analysis is very difficult to establish because the calculation is impossible for future climate damages which stay uncertain, and the example future cost of adaptation too. The effect of climate change are very different between countries, and the developing countries are the worst placed to adapt to global warming. At the international level, COP16 decided to create a green fund is not precise. Of areas, hills, agriculture, building, natural and industrial risk, insurance. But it's not the, I'm sorry. We have a lot of other areas which are concerned. For example, the source of the growth of Ebola is deforestation and reducing of biodiversity in West Africa. Adaptation imposes the contrary, how can live the population? For agricultural, the agroecology which is proposed by FAO is a good answer as policy adapted. The result in Madagascar, in the north of India, or in Nigeria are concluent, but we continue with an agriculture which consumes a lot of water and entrance. For the building, we now construct to protect population against the inundation, and we know that it is dangerous to build in certain places, but we continue to build on the coast, and the construction adopted are more expensive in the country. The best answer is the local answer. Cities for Climate, the R20, give a good example of local authorities which want to promote sustainable development. But the most important stays in the population, the business, the NGOs, and the consumers' initiative. The success of the movement depends on three factors. First, the truth of ecological prices. The internalization of external cost is an absolute necessity. It is while we deny the cost that we can continue to be irrational. The confidence in the governance and the authority. It's impossible to act if the good information is not clear and if the information is not sure. And third, the new economy. The new economy is the third industrial revolution, is a sustainable industry, which is vital to our future economic health. It will be at the forefront of any fight against climate change and environmental degradation and any transition to a resource-efficient society. For that, increase efficiency in the use of resources by industry while boosting economic development, decent jobs, and improving quality of life. Incentives, including state aid, to promote sustainable industrial practices while phasing out aid to unsustainable processes. public procurement to be used as a powerful instrument for stimulating innovation and driving markets towards sustainable products and services. Pursuing active energy-saving policies and diversification towards sustainable, no-polluting, and safe energy sources in major industry sectors such as transport and construction. The challenge is not in the industry of the past, but of the future. The third industrial revolution, Internet of Things, sustainable cities, smarter planet, are the new initiatives of the network open, distributive, collaborative, and green. Thank you for your attention.
You can speak from your chair or from here. It's up to you. But please use the mic. Our next speaker will be Jerome Zerang, previously introduced. Man who's, again, probably more at the epicenter of needing the knowledge, understand the difficulty of applying it, and trying to command the resources to do the things that might be possible. Jerome?
Thank you, Mark. And if I may, I'm from Thibodeau. Oh, I think I messed this up. I'm from Thibodeau, live in Houma. So again, I'd like to apologize for my English as well. 40% of the nation's wetlands, we are experiencing 80% of the loss. One of the most valuable ecosystems the world has ever known. In fact, some have said the loss of coastal Louisiana is the greatest ecological disaster this country has or probably ever will face. I'm somewhat biased, I would tend to agree. Associated with that, on now 2.7 billion in losses in average annual, associated with average annual damages, just living on the coast, the vulnerability that exists. I spared you all the maps and the presentations and all the slides, but looking at worst case scenario and the projections and considering what we're here talking about today, the reality is that could increase to 24 billion per year. How can a coastal economy sustain something like that? $24 billion in average annual loss. Not to mention, you've probably lost additional 1,700 square miles of our coast. We've lost 1,900 square miles, and projections are if things continue unabated and as they are, which I hope to address. And I'm somewhat optimistic because after I give these talks, people generally say, geez, man, God, is there anything we can do? Is it too little, too late? But I say, buck up, little trooper. We have an opportunity to make a difference. We'll never get back what we have, but we have an opportunity to develop a sustainable ecosystem and a viable coast for the community and the habitat and the resources that depend on it. And I'm very thankful, Dr. Burkett, to mention the master plan. And she's right. We have factored in issues associated with sea level rise and also Dr. Bosch. And I respect the heck out of both of those, you know, Dr. Bosch and Dr. Burkett in terms of what they've done for Louisiana, what they continue to do. And recognizing the fact that a lot of the problems we have or are experiencing and the issues we're facing were based upon decisions, no one in this room, and a lot of the decisions that were made knowing that implementing these decisions were going to have far-reaching and significant impacts well into the future, and those decisions were made. Obviously, completely changing the hydrology and the ecosystem of our coast, replumbing it, fixing where it is. And granted, I'd like to give our forefathers the benefit of the doubt, and knowing what we know now, chances are I don't think they would have implemented the protection measures they had similar to what they did at the time. I would hope that they wouldn't. And I think we could and should have done things differently. But we have to deal with what we have now. We have to deal with the fact that we have a habitat that there is no other place in terms of dollar value or poundage produces more seafood, in terms of critical habitat, migratory waterfowl, neotropical migrants. The oil and gas industry, although it is, in addition to fixing the river, has impacted our coast in addition to forestry, herbivory, many different factors that affect our loss. But there are things that we can and should do to correct that. And part of which, as Dr. Burkett mentioned, is this master plan. And I'm not going to sit here and tell you that we've solved the problem and this is done. It's not perfect. It's about the most perfect plan we have. And it's probably, at least to the credit of the good folks who've worked on it, many scientists in industry and focus groups that were embedded in the process, probably the most apolitical process when it comes to addressing this issue of fixing our coast. And it's also a process that when people often ask, how can I get involved, or what can we do, or is there something being done? Well, the plan is designed to the degree that we know it's not perfect, and it is an adaptive plan. It's a dynamic coast. It's going to take a dynamic solution to address it. We have to go before the legislature every 5 years, and we're in the process of doing the 2017 plan. So then one of the things, if people often ask, how do I get involved? Get involved with the focus groups, get involved with the framework development team, come to CPRA meetings, get engaged with the process so you can influence how this dynamic plan is developed and will continue to address this issue of coastal land loss in our coast. So there is opportunities, and there is an adaptive process to factor in things that we don't know, things that we're learning, the uncertainties, to ensure that we're using the latest in science and technology as we move forward in addressing this issue. Again, we'll never have what we had, but we do believe that we can achieve a sustainable coast. And in regard to sea level rise, I know that's a critical concern and issue in terms of what we're doing to address that within the plan. And just a few little notes I wanted to highlight here is that the CPRA utilized a large body of experts' opinions to establish the future scenarios of sea level rise. We had an independent scientific review. We engage independent scientific review in both the modeling, extensive modeling. I typically do a model whether I'm going to get out of bed in the morning. We do models so much, but they're important in terms of assessing our ability to determine what we're going to do. The models look at what the coast will look like 50 years from now if we don't do anything. The models also look at what can we do if we start implementing these plans and projects. The master plan incorporated important marsh accretion and sediment processes. The master plan imposed relative sea level rises ranging from 0.5 to 4 feet in the moderate scenario. We looked at basically two different scenarios, a moderate and a worse or less optimistic scenario where it's 1.1 to 5.6 feet under the least optimistic scenario by 2060, depending upon the location. And the master plan evaluated how all of the projects performed under both those scenarios. And we chose, or the plan, the folks that helped build the plan, are utilized in the least optimistic scenario in terms of advancing our projects. But it's important to note that most of the projects, I'd love to say all, but most of the projects performed well under both the moderate and least optimistic scenarios. The plan is to help restore and protect our coast. It's also to have a sustainable community and coastal communities, and working toward not only protecting and reestablishing the habitat who utilize the resource, live in this beautiful place, and provide these valuable resources to the nation. And again, I would encourage you all, coastal, give it a .gov. You can see the plan. You can also get engaged. Addresses social issues. It addresses the habitat issues and the resource issues that are going to be important in determining how we're going to address this issue of coastal land loss. And I appreciate the opportunity to come and talk to you today.
And for those of you who have not actually taken a look at the plan, I recommend that you do. You'll find things you like, you'll find things you don't understand, you'll find things you disagree with. But that's the way it's not surprising. In many ways, it's probably as good an example of the kind of thinking and decision making that's going to be required. And it's, as he noted, it's not a one and off. It is to be revised every 5 years. And I would certainly think that, I know that the last version of the plan looked quite a bit different than the first version of the plan. Finally, we're going to have Dr. Daniel Zimmer. We've talked a lot about sea level rise and sort of precipitation patterns and shifts and the like. But climate change affects more than coastal areas, and it comes It affects more than just, communities facing storms. Water resources and the management of them is essentially the story of much of civilization. How water resources are made available to us and how they will be affected by the changes that are anticipated is going to be one of the challenges, of our lifetimes and probably those who follow us. That's why I was particularly delighted when Dr. Zimmer was put on the panel, because this one comes close to home. Dr. Zimmer?
Good afternoon, everyone. I prefer to sit here because I think people in the back will see me better. So it's a pleasure to be here this afternoon with all of you. I've been working in the water area for quite a number of years. I have moved today to a more different subject, I have to say, although my heart is still close to water issues, but I'm working in a new European organization that is called the Climate KIC, where KIC stands for Knowledge and Innovation Community. Typically, Climate KIC is a large partnership of more than 250 organizations that try to not so much develop policies or science about climate, but really to develop action and to innovate, because we are convinced that climate change poses new challenges, and our societies need to change the way they look at their economies, try to develop new models in order to adapt, but also to address all challenges related to climate. I have been here after Katrina. I remember very well. It was the city was still not in a very good shape as it is today. And I was there for a panel that reported to Ban Ki-moon on water issues and on water-related disasters. What strikes me still today is how much risks and climate-related risks are not only natural risks, but they are very much related to the way human activities also impact our environment. So here it's very clear the risk is not only about water, about climate, it's also subsidence of the land. It's also the density and the areas which are occupied by the people which make the risk, which build the risks that we need to deal with in particular, and in addition, of course, if there is an increase in extreme climate events. Adaptation, what I learned in these years is that adaptation is not an easy thing. It's, and I think Corinne Lepage explained it, it covers a lot of different areas. And when you want to deal with adaptation, you need to look at not only climate and not only extreme events and the consequences. You need to look at several different areas in the economy, in society, in agriculture, and this is, I think, part of one of the reasons why it is today difficult to develop policies related or addressing climate change issues. And my statement this afternoon will be that we do not necessarily need policies to address climate change adaptation, but we need framework for action. We need to be able to, in fact, address two different things, to look at two different costs, because when you deal with adaptation, a lot is about money. How much will it cost to do something, or how much will it cost not to do anything? And these two things, the cost of inaction and the cost efficiency of different actions, should be the basis of our of a framework for action that we need, that we or practitioners, scientists need to provide decision makers. At the moment, this is what I've observed, decision makers are puzzled. They see the different consequences of climate change, but they do not necessarily see where they need to act. And so they need to know if they act in a certain area or if they don't act, what will be the costs of not doing things, or what would be doing things. We have these global data and information at the macroeconomic levels, so, but we don't have them more at the local level, and this is very much missing. One of the reasons also is that when you deal with extreme events, it is very difficult to understand all the cascading effects that these events will have. And so it's difficult also to know what is the cost associated with all the risks of climate change. And we need to develop tools to do this. And if, on the other hand, we would be able to propose a number of measures that will increase the resilience, then politicians, policymakers would be able to compare what would be the costs of inaction and the cost efficiency of different types of action, and then they would be able to choose, is it enough to be better insured, or should we already start to implement protection measures or different types of prevention or other activities that will increase the resilience. I don't want to enter into more details about this, but I want to give you one example of something that we do with the insurance sector in Climate Kick. Insurance sector has to play a very critical role. Basically, when you work with insurance, you understand that the knowledge of this sector is very much about the cost of inaction. If you pay a premium to be insured, it's basically the costs of the risks related to living in a floodplain or facing inundation risks, for instance. So for us, working with the insurance sector in Climate Kick is really starting to address this first and important issue of cost of inaction. So we have developed a platform which is called Oasis, which is completely open source and which can be used by the insurance sector. We have at the moment 44 insurance companies working with it. And this tool can compute, in fact, the financial risks of an insurance company. But what is interesting with it is that it can also be used for any risk assessment tool to be plugged onto this core tool and to bring the knowledge on risk by the scientific community. So we have quite a number also of cities or companies, consultancies working on risk management that can bring their knowledge, plug this knowledge onto this core element, which will compute then the financial risks of the insurance companies and then help them define better the premiums they need to charge their customers. So this tool is the basis for us of a new approach also, where first of all we will have the capacity to have a much greater transparency in the tools that are used to compute the risks for the insurance sector. What you need to know is that at the moment, all insurance companies refer only and use only 3 available tools, which are completely untransparent as related to the risks that are the modelization and of the risks that are used by these by the three companies delivering this service to them. So this will be a game changer also in the insurance companies, which is very much pushed by the European Union at the moment, willing to increase significantly the transparency in the insurance sector. What we see now is that using this approach and working with a relatively small 44 insurance companies, but we will start working in general in three directions with the insurance sector. The first one is to help the insurance sector address themselves climate change. A recent study in the United States of 300 insurance companies has shown that only 3% of the insurance companies are well prepared to climate change. Surprising. And also, what is less surprising is that these 3%, only 9 companies actually out of 300 are reinsurance companies who are accustomed to deal with natural hazards. But it shows also the amount of work that needs to be done with the insurance sector itself, which needs to really start thinking what will be the increase of exposure related to climate change that they will need to face. A second direction that we are trying to take at the moment is to work with a number of insurance companies on the damage reparation, rehabilitation of houses, properties that have been damaged by a disaster. At the moment, only a few of the insurance companies have taken this approach, but we feel that this is a very important way also to increase the resilience of houses or properties that have been damaged during this rehabilitation. And the third direction that we are taking is to help also the insurance to spread and to be to develop in areas where there is at the moment little insurance or at least a low coverage of insurance, in order to also raise awareness on the need for adaptation in different sectors, in countries or regions where the insurance coverage remains very low. So in this way, we will progressively start having a much better understanding, at least of the cost of inaction, and in a parallel way, which I will not develop, we are working on a number of measures that increase resilience and look at the cost efficiency of these measures. So this is, at least briefly, some of the things that we are doing in Europe. And I would be, of course, I will be happy to exchange also with our US colleagues here and develop a framework for action to scale up adaptation to climate change. Thank you for your attention.
Well, all the questions have now been answered. I guess we can go home. Obviously, we're sitting in a very vulnerable place. And most of us, when we look at those dots that were on Professor Tornqvist's slide, realize that there are a lot of very vulnerable places in the world with lots and lots of people. But most of those, and I would venture to say all of those places, were put there for a reason. And it was a value-driven reason. So I'd like to build on the kind of, the cost discussion that Daniel just got us into. But in addition to getting a better handle on the relative costs of doing something or not doing something, do we have a better idea of really from taking one course or another? Because I don't think anybody ever would have put a city where New Orleans is, or where Amsterdam is, or where Jakarta is, if your goal was to have an easy relationship with nature. We did it because there was an easier relationship with building wealth and commerce. Is there anything to this, or is this just a pipe dream? I'll start with Ms. Lepage.
Yeah, just take it off the stand.
Thank you. Thank you. It's late, that is true. But I think that investment in adaptation is the best investment that we can do today. Because it's a new economy which emerges. And I say that the choice is not between the old activity and the new activity. The choice is for the new activity, for the new jobs. And I think that we have to understand that we change a world. It's a new world today. And it's true that it's expensive to invest. And we think ever that we can wait for. But no, for economic reason, we don't have to wait for. We have to invest and invest today. And it's the best investment, in my opinion.
Not only invest, but I think evaluate how we invest. Typically, and it's just the reality, we are a reactive environment, government, in terms of we wait for something to happen. I mean, there are projections anywhere from 1 to 4 for every $1 invested, $4 to $11 benefit, and proactively addressing the issues in terms of what we've hope to approach or will approach within the implementation of the master plan, building stronger, building smarter, reassessing where we are building and how we're doing it in terms of recognizing that we can't protect everyone from everything, and identifying what are those critical resources, what the risk, educating ourselves as to what the risk is and what are the costs associated with either investing to protect that risk or evaluating either a better way to approach our perspective in terms of investing in that risk. Within the plan, again, we could spend hundreds of billions in dollars in protecting and restoring our coast. It's settled on $50 billion, and 1/5 of that is associated with non-structural measures in terms of creating resiliency and protecting the community. We also have protective features as well, but working on trying to both incorporate and integrate the economic aspect of restoration and the protection that it affords, in addition to the benefit, but also how we can integrate that in our approach in developing projects to create that resiliency. It is what it is. Living on the coast, we are going to be vulnerable. And I think Thor said it was Miami. Well, not that I'm happy to hear, but it sounds like if they're going to get it, they're going to get it before us. But in terms of in New Orleans and how we're protecting ourselves, but we are, in fact, for the most part, the canary in the coal mine. The things that we are doing now and implementing are going to be measures that can be applied and will be applied, not just here in coastal Louisiana, but also on the east and the west coast. And also, I know Mark and I were in the Mekong Delta about 9 months ago and looking at similar issues and the problems that they're addressing, no different than what we have to contend with. But it's a matter of both recognizing what that risk is and best investing in how to minimize it as best we can.
Maybe a comment. I feel that we are indeed a bit schizophrenic because we put value on things which are not necessarily reasonable. So most of the population likes to live in areas which are close to the floodplain or coastal areas, despite of the fact that there is an important risk. So we know a lot, but we don't act accordingly. And so I guess that this is probably something also that we need to collectively learn better, and I don't know how to do it, I have to say, but it's obvious that everywhere in the world there are areas that are flood prone, that are really dangerous, but it seems that people still want to live there, and so learning from the past, have a collective also learning of the risk and become a risk informed society is probably also a value that we need to create for the future.
And I think Jerome's admonition that they can't protect everyone from everything is apt, but you can protect me from everything, can you not?
And that's a priority.
I just wanted to make sure that we're straight on that. Kind of the problem. A big part of the conversation that Daniel put up was about the role of insurance. What it hasn't been and what it may shape up to be. And anyone who is focused on the flood insurance and property casualty insurance in the United States knows that we are this close to a very, very significant change in the way we live. I mean, we came very close to having vast areas of the United States, not just Louisiana, effectively made uninsurable in any conventional sense. And that may be back in a few years. But that said, as we look forward to the climate talks coming up in 2015, can we expect essentially the business community to play a different role? One that is actually looking more at the anticipation of both reducing costs and creating value? Will we expect, if you will, let's say, institutional investors who are increasingly looking at how safe the environmental climate is for their investment, not merely the traditional financial? Is that something that we should be expecting in Paris in 2015, do you think?
Well, from a business perspective, if they were smart businessmen, I would assume that they are, and incorporating some aspect of that. There's no doubt that as the vulnerabilities increase, so is the exposure as well. And in fact, some will contend that in terms of whether or not how we live or where we live in the coast is being determined more so by insurance as the factor of social engineering, and so much as if you can't insure it, if there are no schools, if there are no communities, if there are people who aren't going to invest there, the reality of the likelihood that that community will survive into the future is greatly at risk, along with the infrastructure associated with it. But I would contend that, yes, that is going to be a factor, but I think it also can be an opportunity. I think there are ways that we can use the business community as an incentive to get them to appreciate that there are opportunities in both protecting and creating that resiliency within our coast, and the value associated with doing that, that hopefully that in addition to the business aspect in terms of protecting their investments, looking at protecting the coast and making it more resilient is an investment in and of itself.
Not sure whether this will be or should be discussed in Paris, but I observe a number of interesting trends, especially in the financial community. Recently, another report, interesting report that was released is a report by a new organization called the Asset Management Disclosure Project. It's a big project that is pushed by the financial community and by I don't know how many financial institutions, that requests from asset managers, which are different real estate managers or industry managers, to disclose their policies related to adaptation to climate change. And I don't remember how many of these asset managers reported, but several hundreds started to report. And I see this as a new trend because the financial community is becoming more and more aware that the climate change will increase the risks for these asset managers. And so they want things to change. And I think this will probably could be an important driver in the future to make the action of these asset managers evolve.
Thank you. Oh, sorry. I think that insurance is a very good tool to move the situation. First, the cost of natural catastrophe is very important since 10 or 15 years. And the system is not sustainable because it's too expensive. We have to change. Insurance can conduct industry and population to invest to reduce the cost, and can too punish the same persons which don't want to invest. And it's a very good tool to induce good choice for the people. And it's very interesting. And in other way, for example, we speak at during the dinner of the oil pollution. The question of insurance in states is very important to avoid pollution. We have not the same system in Europe, and we have a lot of pollution. That is the proof that with insurance, we can change the system.
So do you see a way of actually putting a cost on things that drive, climate change? Because obviously, if it's not a cost, it doesn't get managed for, and that is one of the issues that you bring up. How do you see that being, and that's the entire idea behind carbon taxes and the like. Do you see, what's the future for that in your opinion? I mean, is that the kind of tool we're going to build our toolbox around, or are we going to look at something more diverse?
You go first this time. We're ringing around.
Yes, having a price to carbon, of course, is something very important. Again, a lot of stakeholders do not wait until a general carbon price is decided internationally. We see today a tendency, in Europe at least, of private companies, large businesses, to adopt for themselves in their activities a carbon price. So it means that a large corporation like Veolia, for instance, has put price tag on the carbon, and in order to drive their internal business in the right direction. So it shows that even big businesses at the moment have understood that this could be a very interesting tools. Will come up with some proposals on this.
Thank you. I think that tax carbon is a good solution to internalize the cost. And we need from price signals, and it is price signals. We try in Europe with the market of carbon, but it's not a success. It's not successful. And for this reason, European Parliament discuss on the question of tax carbon in Europe, but if we go in this direction, it's necessary to think about the world on this point. And another point, which is important. I think that a day, I don't know when, but a day, we have a trial against polluters from CO2. And in states, you have a decision of Supreme Courts on this point. At the day where the polluters pay the cost of carbon, it will be more expensive than tax carbon today.
Thank you.
Hey, what about me? I don't get a shot? Oh. And in fact, Louisiana has embraced and utilizing the aspect of carbon trading. In fact, we've developed the first methodology in VCS for carbon trading for avoided conversion for wetlands. We've developed that methodology. And who would have thought 10 years ago that when we're executing contracts with landowners right now, for most of you may not know, 80% of our coast is in private hands. So when we go to do projects, we have to deal with private landowners. It's the way it is. They're now incorporating in their contracts, in real estate contracts, the aspect of carbon. It's amazing. But the reality is, if we were to do a project, the attorney fees would exceed more than we would get for those credits. But that's just inherent in the problem it is right now.
I feel I understood the problem there.
No, I think that you obviously have hit on the problem. But unfortunately, in a voluntary market, the value isn't there right now. So hopefully we get to a point where we can actually exceed the attorney fees if maybe we could get more reasonable.
Well, and we take that as an important announcement that the state is supporting a carbon tax.
Oh, no, I didn't say that.
Sorry. I'd like the process from here. I'd like to thank this panel. Magnificent job. And I'd like to invite the other panelists to come up and join so we can actually have a little bit of broader Q&A. We have been collecting cards from those of you in the audience. Needless to say, in the next 30 minutes, we're probably not going to get through all of them. But this is what we will try to do, is that if we don't get to the questions that are on the cards, we're going to take those and we're going to still try to get them answered, and we'll be able to post the responses, at least on my institute's website. So we'll try to, again, keep this conversation going, because the idea is not limit discussion, but to begin to expand it. And, right. Yes. If this is in front of you, you're prone to say stupid things. Well, the first question that we have from our audience does involve looking forward to Paris in 2015. And that is, how important is the U.S. role going to be at this next round of climate talks, and what might that role desirably be from your point of view? Let's start with Dr. Bosch. And if you don't know, feel free to say you don't know.
The international solution on carbon emissions, on greenhouse gas emissions is, I'm not a political scientist, I don't know all the dynamics, but if you just have to look at the budgets and the sources, the two largest emitters are the United States and China. So I think my own view is that's all going to hinge on whether we can find some solutions between those two nations that make that work, and then that could have to interact with the rest of the world to find compatible solutions. But without those two players coming to the table, seriously, I'm not optimistic.
I think that the role of states is very important for the next meeting in Paris, in Lima, and after in Paris. And if America block and don't want to progress, the risk is an agreement between the rest of the world, with China and Europe, and the America stay outside. I think That is the risk. And second point, the business, the industry, which decide to go in green economy and the third industrial revolution are the leader from tomorrow. The best example is China with solar industry.
I'm just hoping I could swing a trip and get over them. I think that obviously it's important, and from the perspective, from our state's perspective, I think there are many things and examples that we can point to, and hopefully that can help guide and foster some of that discussion.
Well, I don't know if I have any response to the question, but my question when listening to the first panel was, are the climate scientists in the US having a role at the moment in getting awareness with or increasing the potential or the possibility that the US would play a role? And so is there any form of organization that is in place to make this happen? So I don't know if you can answer.
Actually, this question I can answer more easily than the previous one. I think Don Bass actually made a very good comment earlier on where he pointed out that his experience was that it's easier to work with the state government than necessarily with the federal government on these issues. Now, I have to add that depends heavily on which state you live in. You know, in Louisiana, the situation is complicated. I think, you know, Z mentioned earlier that the master plan deserves a lot of credit for fully adopting IPCC-based scenarios for sea level change. This is not something that happens in some other states, which I will not mention. So in that sense, we're doing good. On the other hand, our congressional delegation is, the vast majority is basically in complete denial about climate change even being an issue. And from that point of view, it's coming back to what I said at the beginning, it depends very much on, you know, which state you're talking about, what the prospects are. And from that point of view, the situation here is not good.
I think the situation has dramatically changed with respect to our greenhouse gas emissions at the time of the negotiation of the Kyoto Protocol and now. And I would like to tune a little down what was said before. Of course, there's a question of US leadership on this topic. But I think a lot of the game is between the developed countries and the developing countries. And if we don't manage to have an agreement between these two worlds, there's a 100% chance of failure. And what I see is also emerging bilateral agreements between the US and other countries with respect to minor climate drivers such as black carbon, methane. And my main worry is that if there's so much focus on minor components with side effects on health and so on, which are important, and we neglect engagements on CO2, which is the key driver, it's also a way to a big failure, not in the negotiations themselves, but in really managing to limit climate change.
This is a policy level question that it would be more appropriate for someone from our State Department in the United States to address as far as national policy.
Fair enough.
But I will say, and Valerie and I both had the experience of going through in the IPCC plenary session where the delegates from the UN member nations came, and I expected, this was my first, it was in Kyoto, Japan, not Kyoto, Yokohama, in March, and it was like your working group. We went 4 days and 4 nights. Our chairman stood at the panel at the podium for 36 hours. He broke for natural reasons, but we went all night long. And the cool thing about it
I,
was.
I will not second that motion for this
Okay,
evening.
well, but the most encouraging thing to me as a scientist was, out of all that were out there, and they'd go to Japan and they'd put up their thing like this, and then they would be called upon. We had like 7 people from the United States that took turns sitting at the table. The points that they didn't try to change the science. I don't know how your experience was with Working Group 1, but it was to help with the translation. Like the people from Africa wanted us to use the word drought instead of changes in hydrology that are brought about by changes in temperature combined with changes in runoff. Why can't you say drought? And it got louder, and we changed it. That table now says drought prominently. So, I am encouraged by that. I'm encouraged by, I think since 2007, since the AR4 report came out, it was like someone flipped a switch on the wall in terms of people understanding and trying to become educated about the facts. And I see that. And that's probably, I should stop there. Thank you.
I can certainly say the word drought gives poets a whole lot more to work with. I want a quick follow-up for Z, because this was a question. In the state's master planning process, are its assumptions about the less optimistic scenario based upon, the updated IPCC rules or, projections, or is that a moving target, or, how are you handling that?
Well, that's one of the beauties about the whole system, is that we will incorporate and evaluate new and more recent science. And in the 2017 master plan, we're going to evaluate the assumptions that were made on those projects and look at the latest in the modeling and improving the modeling. One of the things that we're doing is, as we continue to advance the assumptions that we made, also improving the models to what those assumptions are based on. So to answer your question, I believe, and I think it will be, incorporating new assessments as well.
I kind of want to follow up on the points that, in fact, that Virginia just brought up. And it is one of the questions we have here, and that is, for all this big planning and big talking and choice of vocabulary, what's the role of local communities and indigenous groups as we sort out this climate science, and how will that engagement affect the result? I mean, it sounds like in some ways, at least from a vocabulary standpoint, it already is.
In our U.S. National Assessment, we have a chapter on indigenous peoples, and we involved Native American tribes from around the country. So in the first National Assessment, there was nothing like that. The second National Assessment, we touched on it briefly, but now that we have the ability to project changes in the arid Southwest and the changes in Alaska, and Tor, you said Miami? We're already moving 20-something communities off the Alaskan coastline because the coast is collapsing due to permafrost decline. The sediments are bound with ice, the sea ice is retreating, sea levels rising, and Arctic storms appear to be intensifying. So there are a lot of vulnerabilities, and some of those involve Native American peoples. So the best sort of Native American assessments are written in part by those Native American people groups, and this indigenous knowledge. There's an emphasis growing in the United States when we do an assessment to include. And so if you read our latest report, there's a chapter that was co-authored by Native Americans, informed by climate scientists from around the country. But you see that growth. One of the conclusions from the Working Group 2 report of IPCC was that the marginalized and where marginalized populations for reasons of poverty or violence or whatever, those are probably the most vulnerable peoples. And it's not just confined to developing countries. There are some developed countries. New Orleans is often used as an example of where there's high vulnerability, but it's a developed country. But I think we'll see more emphasis on effects on indigenous peoples as a result of these conclusions that just came out about their high vulnerability, relatively higher vulnerability for the large part.
I have a question of more general application. That is, carbon dioxide seems to get most of the glamorous press amongst greenhouse gases. But other greenhouse gases like methane, certainly are significant contributors to what can drive climate change. Why do you think CO2 gets all the press? And in light of natural gas, production in places like, Louisiana and the United States, should we be expecting a greater emphasis on methane emissions?
So why is there more attention on CO2? It's for three main reasons. First, today it's the largest climate driver related to human activities. Methane is second. The second reason is that it has a long lifetime, and 30% of today's emissions will still act on climate in a 1,000-year time scale. So it's really a question of the irreversible aspects related to the behavior of the carbon system. And the third aspect is ocean acidification, for which this area is also vulnerable, which is a side effect of CO2 emissions. With respect to the development of shale gas, for instance, I think the key topic is the full climate impact from exploration, transport to consumption. When comparing shale gas as an energy source with respect to, and that's a separate topic, which requires monitoring of emissions.
Just to add what Valerie said, because of the much longer life in the atmosphere of CO2, we won't get another chance. I mean, you could postpone dealing with methane, and it's not going to last for several hundred years. CO2 will. The other thing about methane in production here, and reliance on methane, there's this big debate raging about whether that's a good thing, or because it's less carbon intense, is a transition to a fossil fuel free energy future. And indeed, the Obama administration has supported that notion. The key determinant of that, and in my mind, the key issue in all of the debates about fracking, hydrofracturing, fracking, is this issue of fugitive emissions. Because as Valerie pointed out, if you take the full production, and if you're actually leaking only a small amount of the methane, you undo the potential less carbon intense benefits of going to natural gas as opposed to coal or oil. So that I think should be the real focus. If we're going to rely on this, we really have to control our emissions. And it isn't just, by the way, emissions in the production and transportation systems, but we have serious infrastructure, distribution problems and leakage throughout cities with old infrastructure. So there is a downside of more on so-called clean natural gas because of the emissions, fugitive emissions problem.
If I could,
one word,
please.
Yes, we begin to work on this point at the level of Europa for the tar sand in Canada, because we try to calculate the impact of the tar sand with the impact of oil extract in normal condition. And the difference was from 25%. And we propose to tax the difference. We vote in the European Parliament on this point, but we lost in the Council. But it was a direction.
Sort of a related question, and that is, assuming we do move toward cleaner energies, which is going to reduce the amount of particulate matter in the atmosphere, which was noted earlier, maybe actually a buffer to some of these effects of CO2 and other greenhouse gases. A, how big a deal is that going to be? B, is this a situation where it's part of the pain in order to get to gain? And thirdly, how do we explain this to people so they'll know what they're seeing?
Maybe the audience didn't fully understand Mark's very tricky question. But if we reduce the reliance on coal and go to other sources even renewable sources, one consequence of that is the reducing the particulate emissions that go into the atmosphere. And as it turns out, that is buffered the greenhouse gas effect. And so it's had a cooling effect because of the shading. And so if we actually are transitioning to the renewable energy or even natural gas, and as a consequence of that, we're reducing those particulates in the atmosphere, the aerosols, then that could heat up the planet faster than it's been heating up because of that, of the reduction of that. The IPCC report showed that that was not at all an inconsequential effect, and it's one of the things we have to do. You know, in the end of the day, though, is that we really have to get off of these emissions of greenhouse gases. So I think that's going to have to be something to be managed. There's no excuse to continue to burn coal, just simply of continuing to provide us this shield.
Please.
One word. We try in Europa to go in this direction with the third industrial revolution, and I think that the best example is Germany, because the emission of gas decrease importantly, the industry as well, and the growth of renewable energy is very important. From 3% in 1990 and 26 or 7 today.
And it's a policy of a conservative government, too.
Yeah, it's yes, but in German, the politic in favor of green activity and the less of nuclear reactor is a choice of conservative party.
Thank you. Well, the next question, if you think that was tough, is that it's difficult for most people to care about much of anything that exceeds their lifespans. If that's true, and I probably say it is, how then can we convince the general population that we need to act now when the projections for climate change often don't play out until 2050? And I think, you know, I would say that I would expand that. It's not just for individuals, but you know, for governments beyond the electoral cycle, businesses beyond a budget cycle, you know, legislators beyond a legislative session. How do we get out of this trick bag?
Well, a first reaction on this is that climate change is now. I think at the moment the people working on climate change have not done their job properly in showing already where climate change is hitting our societies and economies. If you look at in France, for instance, the harvest dates of most crops have been earlier by almost 1 month, or three weeks to 1 month for most crops. How can you imagine if this has happened that other aspects have not changed? The problem is that we don't have a good framework to analyze all the changes and monitor them at the moment to clearly show to the economic actors what the consequences of climate change are already today in many aspects of the economies. And so I personally always say when I'm asked this question, but don't imagine that climate change is tomorrow. Climate change is today already. And we need to be able to show that it is already occurring in many areas.
Valerie.
I think that's really a very important point. And it has to deal with the timescale of the carbon cycle. So the image that is commonly given is the image of a bath tube. You know, we are filling it with our CO2 emissions, and there are two exits. One is the capability of the ocean to store carbon, and another one is the capability of soils and vegetation. And the more we fill in the bath tube, the more the concentration of CO2 in the atmosphere is going up and climate is changing. So if we want climate to stop changing, we need to strongly reduce the flux of the entrance into this bath tube, and so that it's more or less equal to the capability of ocean, soil, and vegetation to absorb carbon. So if you want the shape of the concentrations to be stabilized, you need to decrease strongly emissions. And that's totally counterintuitive. And there was a study conducted in the US and in Australia that shows that among scientists who are not climate scientists, 70% fail to understand that. Amongst policymakers, the same. I made the test last school teachers, the same. So it's just the way our mind works between fluxes and stocks that is not designed to understand that we need strongly to reduce the flux so that the stock is stabilized. And that's a very important aspect with respect to policymakers. And a few universities like MIT have developed tools. And if you make policymakers play with the tools, they understand it. But they need to afford half a day time to get used to that.
Yeah, I think Daniel Kahneman won a Nobel Prize in economics for exploring the way we model and approach these decisions.
I've got a decidedly less scientific answer to your questions. When I speak to groups, not unlike this group, some gray hair in the group and so on, I take a little time and ask them about their children and grandchildren. And I ask them, how old are they? And I do, you know, those charts I showed you with the increase, and I mark the times of their people they know and love on that time horizon. And then I point out the fact that the only way that those we could go from one scenario to the other, the less drastic scenario, is actions that we take now. They don't have that choice. And so it helps to get people to think intergenerationally on a very personal basis. I think that's part of the approach that needs to be taken.
Very good. Well, we've got 5 minutes left for this panel tonight. And we're going to conclude by giving them each an opportunity to make sort of a closing observation, something they'd like us to remember, be charged with, who knows what it might be. And there was one other point I would point, because it does deal with the question, was not directed to any of the panelists, but it does deal, I think, broadly with what we all are faced with. And that is, for example, what is this university doing with respect to the issues before us? How are we engaging people? What are we doing to change? And I think it's a sliding scale. I don't get to speak for the university, but I do know that we build buildings differently than we do. We're hosting things like this. And quite frankly, what we invest in, from the standpoint of our endowment and the like, will be influenced by the attitudes of the community. Probably not much of an answer, but it's the only one that I can offer in the room today. But with that, I'd like to turn over to the panelists for parting wisdom. I'm going to start at the far end of the table this time. Virginia.
I think this one works. This one works, yeah. My response to your question, your last question, is kind of like the main take-home message. I think the most important thing that this particular group of folks, policymakers, scientists together, a shared understanding of the facts. First big step. That's why a lot of these efforts that we've talked about and described today, the results, I think, are really important. And I would like to also say, this is the first time, and I've been working on this for roughly 24 years. This is the first time I've ever sat at a table with people from a different country, sponsored by the embassies of 2 countries, to talk about the science of climate change and the policy implications of climate change. You know, I think that's indicative of the change and the growth and that shared understanding of knowledge. And I think it's beautiful we've struggled with a little bit of language here today, because, you know, that's basically what we need to problem.
So I think that having this event here was quite extraordinary in the way that this area is particularly vulnerable to climate change and has demonstrated resilience. And it also shows how you have to imbricate the local scale with the international perspective. And the first step, as was said before, was understanding the different points of view, understanding the different perspectives, and understanding each other. And that's the part which is easy. That's the part with the conversation or the talks. And the next, and what we expect from this is action rather than talks.
Yeah, let me make one comment. Since as long as I've visited Louisiana and later moved to Louisiana, I've always been impressed by the incredible awareness amongst the broader public about the environmental issues here, especially here in the coastal zone. And there is also widespread support to address this. We've heard Zia's talked in particular about the Coastal Master Plan and the widespread interest it has triggered. I'm personally a strong supporter of that too, but I have to add that we have to face reality, and that is if we don't address climate change in an effective way, there is no coastal master plan that is going to be successful in the long term. And that's just the way it is. And what I hope will happen is that especially our congressional delegation will turn around quickly and become, big proponents of what needs to be done, because ultimately that's the number one most important thing for this state.
What I want to say in this final to give a final words to this panel is that working with innovation, I see a lot of potential to address many of the issues we are dealing with at the moment. There are many technologies that are already available and that could be deployed at a large scale. And what we see is that at the moment, there are still a lot of barriers, and these barriers are in the policies, in the finance, in the attitude also of all of us. And I'm convinced that, we can do a lot if we really have a collective will to change things. A lot of possibilities exist to act today. And I hope that also the event next year will not be just about policies, but about all the actors who want to act jointly in order to achieve a result that is still at our hands.
In regard to words of wisdom, I don't have any, but I could do no worse than quoting that famous historian Will Rogers, kind of put in perspective and said, basically there are three types of people. There are those who learn by reading, those who learn by watching, and the others just have to pee on the electric fence themselves. And so, again, until it actually comes and shocks them, I think that's part of the perspective. But, though I appreciate, again, the plan isn't perfect. And I keep reverting back to the plan, but fail to plan, plan to fail. And uncertainties aside, we are addressing primarily the critical issues, subsidence and sea level rise, that we have to contend with. In addressing the planet, also, you have to pay for it. And again, it doesn't fund the whole thing, but I think at least from the perspective of the Louisiana folks stepping up, GOMESA and other funding sources are constitutionally dedicated to addressing this issue and implementing this plan. It can't be used for anything else. So in terms of perspective and knowledge, we still have a long way to go. But I think in terms of stepping up and addressing the issue, we're working toward that end. We don't have the answer, but there is definitely cause for optimism.
Thank you. First, I would like for opportunities to discuss with the public and the students, because we can do anything without civil society. Second point, I think that we are the generation which has the chance and the responsibility to change our energetic model. It's an historical responsibility. And the United States have to play a major role in this way. I think that it's very important for all the people of the world.
Very good remarks, Madame Lepage. You know, here in South Louisiana, it's an enigma because at one hand, this is one of the most threatened areas of the world by climate change. And on the other hand, there's this resistance. The reason that Z can't talk about a cap, much less a tax on carbon, is because it seems to be against the interest of an economy that produces oil and gas. If we're hell-bent on getting all of that stuff and burning it as fast as we can, you're spelling your own demise. So that's an enigma. So if you thought about this resource here, this fossil resource, which is probably mostly going to be used because it's valuable oil and gas, it's not coal, and you thought about it is a finite resource, as it certainly is, and it's going to actually probably be more finite than you think because we're going to have to stop using it. You should start to think about how do we use it for the best of our best ability in the long run. Something that's going to be worth probably more next year than it is this year is still in the ground. And if you then thought of how do we use that wealth that the good earth has provided us here to find out how you can transition this region and this society into a solution-based future, think about the vast capacity, if we could develop the technology of carbon capture and carbon storage with these underground resources here. Start thinking about this in a transitional, different way. I think this region could actually be a leader in finding solutions to deal with their really critical problems.
Well, I'd like to thank our panel, and I'd like to thank our audience for and we have a token of our appreciation, which my colleague Chris Dalbaum will bring out for the panelists. But while he's doing that, I'd like to extend everyone an invitation to join us for a reception next door in the faculty dining room. The conversation can continue, and it's just impolite in Louisiana to have any conversation without food and beverages, isn't it?
Yeah, that's definitely, yeah, absolutely.